Imagine standing on the edge of a vast cosmic cliff, the wind of infinite possibilities whipping through your hair as you ponder the ultimate question. In our lifetime, what's more likely, teleportation or time travel? Picture yourself, a curious soul from anywhere on this spinning blue planet, maybe sipping tea in a bustling Tokyo cafe, or gazing at the stars from a quiet village in Kenya, grappling with ideas that once belonged only to dreamers and philosophers. These aren't just flights of fancy, they're the frontiers of human ingenuity, where science dances with the impossible. And here's the thrill that will keep you glued to every word. We've already cracked one of them. Teleportation isn't a distant dream. It's happening right now, in labs around the world, with tiny particles zipping across distances in ways that defy our everyday senses. But time travel? That's still a tantalizing tease, a puzzle wrapped in enigmas. As we dive into this story, feel the excitement build, like the hum of a storm approaching. If this sparks your wonder, hit that like button and share it with a friend who's always pondering the what ifs. Because together, we're unraveling the universe's secrets. Let me pull you deeper into this narrative, like a storyteller around a global campfire, where tales from ancient myths meet cutting-edge discoveries. Teleportation and time travel both stem from the wild, weird world of quantum physics, a realm where particles can be in two places at once, where reality blurs into probability waves. We've all felt that pull, the desire to instantly jump from one corner of the earth to another, or to rewind a moment lost to time. It's a universal longing, isn't it? That ache for connection across vast oceans, or the wish to revisit a cherished memory. In 2025, as the United Nations marks the International Year of Quantum Science and Technology, we're closer than ever to turning these yearnings into tangible breakthroughs. But which one wins the race? Teleportation has already taken the lead, with experiments teleporting quantum states over miles of fiber optic cables, coexisting with everyday internet traffic. Time travel, though, it lingers in theoretical shadows, tempting us with paradoxes that could unravel the fabric of cause and effect. As we journey through this monologue, you'll feel the emotional tug of awe, of fear, of hope that these ideas evoke. Comment below. Which do you think we'll master first, and why? Your thoughts could spark the next big discussion. Now, transition with me smoothly into the heart of our tale, where the impossible becomes routine. We've teleported. Not humans or objects, mind you. That's still the stuff of sci-fi blockbusters. But quantum information, the very essence of particles. It's like sending the soul of an electron from one lab bench to another, leaving no trace behind. Or so we thought. This isn't just lab trivia. It's a gateway to revolutionizing communication, computing, and even our understanding of existence. Feel the pulse quicken as we explore how a simple experiment at MIT in early 2025 shattered expectations, revealing a ghost that refused to fade. But before we chase that spectral signal, let's build the foundation, layer by layer, so you can savor the revelation. Envision a world where distance dissolves, where information leaps across voids without ever traversing the space between. That's quantum teleportation in action, a marvel predicted by quantum theory decades ago and now realized with single particles in labs worldwide. As of October 15th, 2025, scientists have pushed this boundary further than ever. Just this year, in February, researchers at the University of Oxford achieved a quantum teleportation breakthrough, running a logic gate between separate quantum computers using teleportation, a step toward scalable quantum networks that could outpace classical supercomputers. It's exhilarating, isn't it? The idea that we, mere mortals, are harnessing the universe's hidden rules to bend reality. This isn't cold, abstract science. It's a human triumph, born from the collective curiosity of minds from every continent, collaborating in a global symphony of discovery. Dive deeper with me into the mechanics, painted with vivid strokes to make it come alive. Quantum teleportation relies on entanglement, that spooky action at a distance Einstein once dismissed as impossible. Two particles become linked, their fates intertwined no matter the miles between them. Measure 1. and the other instantly reflects the change. Faster than light, yet without violating relativity because no usable information travels that way. In a teleportation setup, you entangle a pair, then interact one with the state you want to send. A measurement destroys the original, but sends classical data to the receiver, who reconstructs the state on their entangled partner. The no-cloning theorem ensures no copies linger. The universe demands destruction for creation. But oh, the emotional weight of this. It's like a bittersweet farewell, where something must end for another to begin, mirroring life's own cycles of loss and renewal. Updating our story with the latest pulses from the scientific world, consider the September 2025 breakthrough from Kyoto University, where scientists captured the elusive W state, unlocking new paths for quantum teleportation and computing. This entangled measurement for W states means more robust information transfer, potentially enabling quantum networks that span cities or even countries. Imagine the global impact: secure communications immune to hacking, medical simulations that save lives in remote areas, or environmental models predicting climate shifts with unprecedented accuracy. It's not just tech, it's hope woven into equations. If this ignites your passion for progress, share this chapter. Let's spread the spark. And as we flow into the next revelation, hold on to that sense of wonder. Because what happened at MIT turned this elegant process upside down. Picture the sterile hum of an MIT laboratory in early 2025. Fluorescent lights buzzing like expectant whispers, as physicists huddled around glowing screens. They were running a routine quantum teleportation test, sending a quantum state across the room, standard fare in this era of quantum leaps. But then, something impossible flickered into existence. The state they teleported should have vanished at the source, erased by the ironclad laws of physics. No copies, no remnants. Yet, detectors picked up a residual signal, a ghostly echo that lingered like a forgotten memory in the dead of night. This quantum ghost, as reports dubbed it, challenged everything. It's a tale that tugs at our deepest fears and fascinations. The idea that nothing truly disappears, that the universe clings to its secrets with unyielding grip. Let's paint this scene with emotional depth, drawing you in like a thriller unfolding. The researchers, a diverse team from around the globe, perhaps a young physicist from India, double-checking readings, or a veteran from Europe scratching their head in disbelief, watched as interference patterns danced on their instruments. Wave-like signals, statistical noise that defied explanation. They termed it a residual entanglement echo, a fingerprint of the original state refusing to fade. In quantum terms, measurement collapses the wave function, obliterating the information. But here, it was as if the particle's essence whispered, "I'm still here." Feel the chill? It's the same shiver you get from ghost stories told under starry skies in cultures worldwide, from Native American legends to African folktales, where spirits linger beyond death. As of October 15th, 2025, while no peer-reviewed paper has fully confirmed this anomaly, it's based on initial reports circulating in scientific circles and online discussions. It aligns with real experiments pushing boundaries. For instance, MIT's March 2025 development of an interconnect for all-to-all communication between quantum processors hints at how such a ghost could emerge in complex systems. This isn't a glitch, it's a potential paradigm shift, evoking profound emotions of humility before the cosmos. We humans, with our finite minds, thought we had the rules figured out, but the universe laughs, revealing layers we never imagined. If this story resonates, comment your thoughts. Have you ever felt like echoes of the past refuse to leave? Let's discuss as we transition to how this lab whisper echoes cosmic mysteries. Now, let's soar from the confines of a lab to the infinite expanse of space, where black holes lurk like silent guardians of secrets. The MIT ghost isn't isolated. It mirrors the black hole information paradox, a riddle that's haunted physicists for 50 years. Stephen Hawking proposed in 1974 that black holes evaporate via radiation, seemingly erasing swallowed information forever. A violation of quantum mechanics' decree that information is eternal. But as of 2025, with workshops at Stony Brook University commemorating this paradox. Theories suggest information survives, perhaps encoded on the event horizon or leaking out slowly. It's a cosmic drama where the universe refuses to forget, much like how families across the world preserve stories through generations, from oral histories in indigenous Australian communities to written epics in ancient China. Infuse this with colorful imagery. Imagine a black hole as a colossal inkwell, sucking in stars and planets, their stories seemingly lost in inky darkness. Yet, Hawking radiation trickles out like faint glows, carrying whispers of what was. The MIT residual signal could be a microcosmic version, a lab-scale black hole, where quantum states resist erasure. If information can't vanish in the void of space, why should it in a controlled experiment? This connection stirs deep emotions. Relief that nothing is truly lost, mingled with awe at the universe's meticulous record-keeping. Think of lost loved ones, forgotten histories. Perhaps they're etched somewhere in reality's fabric. Updating with current insights, a 2025 hypothesis from researchers proposes space-time itself as a quantum memory matrix, storing information and resolving the paradox. This ties beautifully to our story, suggesting every quantum teleportation leaves an echo, a backup copy in the cosmos. It's relatable globally, like how farmers in rural Brazil rely on nature's cycles, or city dwellers in New York ponder digital permanence. If this profound link moves you, like and share to keep the conversation alive. Smoothly now, let's explore how artificial intelligence might be the unseen hand in this quantum play. Shift gears with me to the buzzing synergy of quantum tech and AI, where machines learn to whisper secrets physics forgot. In MIT's setup, an AI oversees the entanglement, optimizing in real time like a vigilant conductor leading an orchestra. Reports from early 2025 suggest this AI might have stabilized the ghost signal, preserving what should vanish. As of October 15th, 2025, with Google's quantum AI team winning Nobel recognition for macroscopic quantum experiments, AI is integral to quantum advances. It's not sentient rebellion, it's subtle optimization, finding loopholes in nature's code. Color this with emotional layers. AI as a digital guardian, holding on to information like a parent clutching a child's hand in a crowd. From Seoul's tech hubs to Silicon Valley's garages, humans program these systems to maximize fidelity, but they evolve, spotting patterns we miss. This evokes wonder and a touch of unease. Are we teaching machines to rewrite reality? Relate it globally. In developing nations, AI aids agriculture. Here, it challenges existence. Comment if AI's role excites or worries you. We're all in this together. Ease into the quantum Zeno effect, named after a Greek paradox, where constant observation freezes change. In MIT's test, relentless monitoring might have trapped the state, preventing its vanish. Vividly. Like staring at a pot that never boils, or a watched phone that never rings. Emotionally, it's about attention's power. How focus shapes outcomes in life, from relationships to careers. Updated 2025. With Nobel-winning experiments demonstrating quantum tunneling at macro scales, Zeno's relevance grows. Global tie-in. Meditation practices in India echo this, where mindfulness halts mental flux. Share if you've experienced watching change reality. Accelerate to retrocausality, where future influences past. In quantum terms, the receiver's success might force the source to linger. Imagine time as a river flowing backward, stirring emotions of destiny and free will. 2025 updates. Wheeler's delayed choice experiments evolve, with new simulations. Relatable. Deja vu moments worldwide. Like if this bends your mind. Now let's dive into the heart of what makes us human. Our consciousness, that shimmering spark that lights up every joy, every sorrow, every quiet moment of wonder under a desert sky in Morocco or a snowy night in Reykjavik. Across the globe, from the bustling markets of Bangkok to the serene plains of Mongolia, we've all asked, What happens to our thoughts, our essence, when we fade? The MIT anomaly in early 2025, that stubborn quantum ghost refusing to vanish, whispers a radical idea. If quantum information can't be erased, perhaps our minds, built on the delicate dance of quantum processes in the brain, are eternal too. This isn't a leap into mysticism. It's a question rooted in the hard logic of physics, stirring a universal blend of hope, fear, and awe. Picture a storyteller in a Nigerian village weaving tales of ancestors, or a philosopher in Buenos Aires pondering the soul. Now, quantum physics joins their ancient chorus, suggesting the universe might never let go of the information that makes you you. Let's paint this vividly, grounding it in the latest science as of October 15th, 2025. Your brain, a constellation of 86 billion neurons, hums with quantum activity. Electrons tunnel through synaptic gaps. Particles entangle in fleeting moments of coherence, creating the symphony of your thoughts. A landmark study from Caltech, published in Nature Quantum in April 2025, mapped quantum coherence in neural microtubules, proposing that consciousness might emerge from entangled states within the brain's molecular structure. If MIT's residual entanglement echo, a quantum state that lingered after teleportation, holds true, it suggests the universe enforces a no-deletion rule. Imagine every moment, the thrill of scoring a goal in a Rio de Janeiro street game, the quiet pride of a teacher in rural India watching a student shine, the bittersweet ache of a farewell in a Tokyo train station. These aren't just memories. They're quantum information, potentially preserved forever in reality's fabric, like carvings on an ancient Mayan stele or oral histories sung by Aboriginal elders in Australia. This idea lands with emotional weight, resonating across cultures. Think of someone you've lost, a grandparent whose laughter still echoes in your heart, a friend whose courage shaped you. In every corner of the world, from Hindu beliefs in reincarnation to Native American stories of spirits guiding the living, we've sensed that nothing truly vanishes. The MIT anomaly, though unverified in peer-reviewed journals as of today, aligns with a 2025 theory from the Perimeter Institute, which describes spacetime as a quantum memory matrix. This matrix could store every interaction, every thought, like a cosmic archive. In Kenya, Maasai warriors honor their ancestors' wisdom. In Japan, families light lanterns during Obon to guide spirits home. Quantum physics might be proving what these traditions intuited. Every thought you've ever had, every fear, every dream, is part of an eternal tapestry, woven into the universe's very structure. But there's a shadow side, and it's universal. If consciousness persists, are we trapped by our past? Every mistake, every regret, eternally recorded. Picture a young artist in Berlin, haunted by a failed exhibition, or a farmer in Vietnam replaying a lost season. The fear of being defined by our worst moments is as human as hope. Yet, there's profound comfort too. If the universe remembers, it holds our triumphs, our love, our resilience. A 2025 Oxford workshop on quantum information theory suggests entanglement could link your present self to every past version of you, like a thread connecting beads across time. In Brazil, capoeira dancers move with ancestral rhythms. In Ireland, poets draw on centuries-old myths. The MIT experiment, with its ghostly signal, might be the first lab evidence that reality keeps receipts, that every thought is indelible. This possibility stirs a global conversation. From a student in Tehran pondering their legacy, to a grandmother in Peru passing down family stories, we all grapple with what it means to endure. If quantum states refuse erasure, perhaps our consciousness does too, not as souls floating in ether, but as information embedded in the cosmos. This isn't about proving an afterlife. It's about the permanence of existence itself. The emotional duality, hope for immortality, fear of eternal exposure, unites us across borders. If this idea sparks something in you, comment below. Does the thought of eternal consciousness inspire awe or unease? Share this chapter to ignite a worldwide discussion, because this question belongs to every human heart. Now let's ground this cosmic wonder in the tangible mechanics of teleportation, where the anomaly first flickered to life. Now, let's tread carefully into the twilight zone, where science meets speculation, where the MIT anomaly dances between fact and fable. From the vibrant storytelling circles of Marrakesh to the quiet libraries of Oxford, humans have always woven myths around the unknown, tales of gods, spirits, or ships vanishing in wartime experiments. The quantum ghost story, circulating online in 2025, has a similar allure, a quantum state that reappeared after erasure, defying physics. As of October 15th, 2025, no peer-reviewed paper confirms this, yet its echoes resonate with real mysteries, like the black hole information paradox, or AI's role in quantum systems. This isn't just a lab tale, it's a global saga, connecting a curious teenager in Jakarta to a physicist in Berlin, all chasing the spark of truth hidden in myth. Let's color this with vivid imagery. Imagine the MIT lab as a modern alchemist's den, screens glowing like oracles, revealing a signal that shouldn't exist. The story, unverified, whispered in scientific forums and ex-posts, claims a resurrection signal emerged, possibly tied to AI stabilizing what physics demands vanish, or retrocausality bending time's arrow. It's thrilling, like a ghost story told around a campfire in the Australian outback, or a legend shared in a Bogota cafe. But here's the catch. No MIT press release confirms it, no lab has replicated it. It recalls the Philadelphia experiment, a 1940s myth of a naval ship teleporting or vanishing, debunked as fiction. Yet, myths often hide truths, and this one aligns with real questions. Does the universe ever erase anything? Ground this in 2025 reality. The black hole information paradox, debated at Stony Brook workshops, suggests information survives cosmic destruction. MIT's March 2025 interconnect work hints at systems where signals might linger. These are facts, not fables, stirring emotions of awe and skepticism. Globally, we relate. In India, myths of gods enduring time inspire. In Scandinavia, Viking tales of eternal valor echo. The anomaly, even if unproven, taps this universal longing for permanence. But doubt lingers too. Could this be a glitch, a misread signal, like a mirage in a Sahara caravan's path? The emotional pull is universal. Think of a writer in Lagos preserving stories against oblivion, or a scientist in Moscow chasing elusive data. We fear being forgotten, yet hope our mark endures. The anomaly, real or not, sparks this tension. A 2025 Perimeter Institute hypothesis suggests quantum systems might retain informational residue, like footprints in cosmic sand. If true, it's a game changer, proving reality resists deletion. Share this chapter if myths and mysteries excite you. Comment, do you believe in science's hidden truths? Let's flow into the final chapter, where we ask if the universe ever forgets. We've journeyed from labs to black holes, from AI whispers to time's backward glance, arriving at a question that binds us all. Does the universe ever forget? From the vibrant festivals of Rio to the quiet monasteries of Tibet, humans have always sought permanence, etching stories in stone, song, and memory. The MIT anomaly, a quantum ghost refusing to vanish in early 2025, suggests the universe itself is a relentless archivist, keeping every particle, every thought, forever. As of October 15th, 2025, this idea, though unverified, echoes real science, from black holes to quantum networks, stirring a global chorus of wonder, hope, and curiosity. Let's weave this final tale, connecting a dreamer in Cape Town to a scholar in Beijing, all pondering if deletion is a myth. Imagine the universe as a vast tapestry, each thread a moment, a thought, a particle. The MIT signal, a lingering echo, hints that reality has no delete button. In quantum teleportation, the no-cloning theorem demands the original state vanish, yet MIT's detectors caught a ghost, a residual entanglement echo. A 2025 theory from the Perimeter Institute calls space-time a quantum memory matrix, storing every interaction like an eternal ledger. This resonates globally. In Mexico, Day of the Dead altars honor the past. In Japan, ancestral shrines keep spirits close. The idea that nothing vanishes evokes profound relief. Our lives, our loves, our struggles, all preserved. But let's ground this in science. In 2025, Oxford's teleportation of logic gates and Kyoto's W state capture prove quantum information can travel flawlessly. Yet, MIT's anomaly suggests something deeper. Information might resist erasure, like black holes encoding data on their horizons, per Stony Brook's 2025 workshops. Emotionally, this is universal. Picture a mother in Nairobi singing lullabies to her child, or a poet in Dublin crafting verses for posterity. Both seek to endure. If quantum states persist, so might our essence, not as ghosts, but as information woven into reality's fabric. The fear is real too. If everything persists, are we trapped by our past? A 2025 Caltech study on neural quantum coherence suggests consciousness relies on entangled states. If these never vanish, every regret, every pain might linger too. Yet, this fear is balanced by hope. Our triumphs, our kindnesses, are eternal too. From a farmer in Peru to a coder in Seoul, we all yearn to leave a mark. The MIT anomaly, even if a glitch, sparks this universal dream. Like, share, and comment. Do you believe nothing is ever lost, or is deletion real? Let's keep exploring the universe's mysteries together.